These are the prototypes we've built after day 1. For a more detailed description and videos of this, you can visit our Chief Delphi or our YouTube channel.
So on the bottom of the robot, we added these 2 skis. They're made out of acetyl resin rods that we cut into fourths. So after cutting into fourths, we then sanded down the corner on each of them so we could create a flat mounting plate onto the base of the robot. And then we cut counterbore holes into the bottom and then screwed it into the base of the robot. We did this because when we just initially had zip tied it on, it got caught and wouldn't slide over. So we did this to reduce friction even more. And then we also cut down the front and the back edges so that it could slide seamlessly over the front of the bump. And then the grand plan would be to add 4 so you can go over it in any direction, which is especially helpful with swerve modules. And we also want to emphasize that even if you're going slowly over, we tested this and it still will not get stuck at the top of the bump because these are so low friction. It makes it a lot easier to get over at any speed.
This is the windmill climb. It comes from level 1 here and then spins upward and then uses a piston to make a wrist so this can detach, and then this can go all the way up to level 3. This climber would use a shortened stage elevator and would lift itself up. This first hook would slide over here and it would be able to latch on without going over the height limit. The elevator would then rise the rest of the robot up, and these hooks down here, there's 1 on each side, would then slide over here. And then now these are latched on, allowing the elevator to rise and bring this one up to the next level, and the process will continue until the 3rd level. This climber latches from this direction, then uses one-way doors to attach itself to the bottom level. And there's a piece in the back to counteract the weight of the robot, so it uses its force as an advantage to hold itself up this way. And then in order to get up to the next stage, there is a hook up here to latch on. This is the backflip climb. The robot drives up to the level 1 bar, the hand pulls up to here and locks on by rotating. Then the gears and chain torque the robot upward, raising it above the level 2 bar, which counts as a level 3 climb.
This is our prototype for an indexer. We're gonna have a big hopper that is feeding in balls. The balls are gonna come through one by one via this mecanum wheel, and it will feed into a flywheel. This is an initial prototype for a flywheel with 2 wheels. Initial wheel is going to send the ball straight up. Second wheel is going to provide backspin. We realize that backspin, whenever it hits the hub, is actually going to make it fall down into the hub as opposed to topspin. This prototype is for an adjustable flywheel. The adjustments are going to be made to test different levels of compression as well as different launch angles. This is a larger flywheel prototype. This is going to have the ability to shoot multiple balls at once, kind of like a dumping scheme. To keep the moment of inertia high, we added flywheels on the side. Moment of inertia is going to help with not dropping our RPMs when we're launching a bunch of balls at one time.
So we prototyped 2 different intakes on our robot. We have this one on the back and this one on the front. The main difference we started with going into it is this one here started with a kicker bar below, and this one started without a kicker bar. By the end of our prototyping today, we realized a kicker bar wasn't really necessary to get the ball up and over the bumper, and both of ours are over the bumper intakes. And then in addition to that, we have some flexibility in both of these. This one has an intentional pivot placed into it, and this one here just has the natural flexibility because of the weight of the wheels in front of it. And the wheels that we tested were cut up star wheels, so we just took compliant wheels, snipped them up to make stars. That didn't work as well, so we ended up testing a bunch of different compliant wheels, and out of the ones we tried, which is the green, blue, soft black, and stiff black, the stiff black definitely works the best. And we found also that as long as we left minimal spacing between them, we have about an inch space between each of our wheels. We never had any issues with the ball getting caught in it. And then we also moved our kicker bar up here at one point just to try a couple things. While this does help with balls that were getting stuck between the main row of wheels and the bumper, it does prevent the balls from kicking up as high, so it's something to keep in mind if you're trying to get into some sort of collection.
Bang! Bang!